Welcome to this video. We're going to learn about something called work. You already have an idea about what work is. If you stand and hold a box above your head for 4 hours, and this is a really heavy box, you might start sweating, right? You think you've done some work after holding that box above your head. But in physics, have you done any work on the box? The answer is no. We can see that physics gives a different definition of work than what you're used to in your everyday life. Here's the physics definition of work. We give it a capital W, and it's equal to the magnitude of the force acting on an object times the magnitude of the displacement on the object times the cosine of the angle between those vectors, between F and displacement. Now in physics, the magnitude of the force, we're going to write that as just an F. So what are we losing when we take the absolute value? We're losing the direction, and so what we're left with is just the magnitude. And this value will always be positive. We always plug in a positive value of the force. The delta R, the displacement, when we take the magnitude of that, we lose the direction. And what is the magnitude of displacement? Well, think about it like this. If your displacement is negative 2 meters, then 2 meters is just the distance that you've traveled, s. And so we're going to write F times s. And then finally, cosine of theta, we can write that as the angle between the force and the distance traveled, or the displacement arrow. So s is always positive, because distance can't be negative. And cosine of theta, this can be positive or negative, we'll see. The cosine can be positive or negative. Theta will always be positive, but the cosine of the angle could be either. And that's the equation for work. In fact, this is the definition of work. The unit of work is equal to the unit of force times the unit of distance times the unit of cosine of the angle. Force has a unit of newtons, distance has a unit of meters, and cosine of theta has no units, so we put a 1. So the unit of work is the Newton meter. And we call a Newton meter, we call that a joule. The joule is defined as 1 Newton times 1 meter. Look back at the equation for work. Do you think work is a scalar or a vector? Take a moment and try to guess. You see force and you think force is a vector, right? Well, we're taking away the direction. And displacement, we're taking away its direction. And so you can probably guess work is a scalar because we're using two scalars, just the magnitude of F and distance. We're using two scalars to define work. So work is a scalar. So let's say we have a scenario like this. There's some object right here, and the object is being pushed by two forces. One is a 2 Newton force, the other is a 4 Newton force. Work is something that's associated with an individual force. The 2 Newton force does work on the object as it moves this distance of 6 meters. The 4 Newton force does work on this object as it moves 6 meters to the right. Let's say the problem tells us to find the work done by the 4 Newton force. That means we're focusing on this force. So let me just take away the other information. Oops. The 2 Newton force, we're going to take that away and forget about it. It's still there. We're just not going to worry about it right now. We have just this force and just this distance. The equation for work that we use to solve is force, the magnitude of the force, times the distance, times the cosine of the angle between those two things, like that. So we plug in the value of force. We always make it positive, 4 newtons. We plug in the value of distance, 6 meters. And what's the angle between the force and the distance? Well, F is like this, the distance is like this, and the angle between them is 50. You plug this into your calculator, and you get 15.4 as the answer. The units, remember, are a newton times a meter, and we call that a joule. The work came out positive. Let's take another scenario. Here's the other scenario. We've got an object which is being pushed by, among other forces, a 12 Newton force right here. There are other forces, and the other forces, in combination with this one, cause the block to move like this. We have to find the work done by this one force, ignoring all the other forces. So the work is equal to the force times the distance times the cosine of the angle between them. The force, of course, is 12 newtons. The distance the object travels is 5 meters. And the cosine here, what's theta going to be? It's the angle from the force to the distance. So this whole amount that I just drew is 180 because it's a straight line. That means this must be 120. And the whole angle from the F arrow all the way to the S arrow, this whole angle is 60 plus 120 plus 20. And so what's that give us? 200 degrees. We plug this into the calculator, and what do we get? It's negative 56.4 joules. That's the work. So the work can be positive and the work can be negative. When is the work positive and when is it negative? Here's the basic answer. Positive work looks like this. Let's do it like this. Here's the distance traveled. Oh gosh. S, the distance. Here's the force. And you see that the angle is less than 90. Negative work occurs when you have an angle bigger than 90. So if the distance is out like this, then you have to have something bigger than 90. An angle bigger than 90. And here's our example. That's negative work, when theta is bigger. The work is positive whenever the force is in the same kind of direction as S. We're going to look at that in more detail. And the work is negative whenever the force is against the direction of S. That's how you can think about it.